All right, today we're diving into a scientific study that could seriously reshape how we grow our food. It's a fascinating story about how a tiny piece of tech might just solve one of agriculture's biggest, most persistent headaches. Let's get right into it. At the very heart of modern farming, we have this massive challenge. The world's population is growing, everyone needs to eat, but the way we crank up our crop yields, well, it's often super inefficient and can be pretty rough on the environment. It's the classic dilemma, right? Productivity versus sustainability. So, to really get why this new tech is such a big deal, we have to understand the problem it's trying to solve. And that problem, it all comes down to fertilizer. We absolutely need it, but our current way of using it is just incredibly wasteful. To really bring this story to life, let's zoom in on one of the world's most important crops, maize, or as many of us know it, corn. The study we're looking at calls it the queen of cereals. And for good reason. It's a total powerhouse crop, but man, is it hungry for nutrients. Now this right here, this chart shows you the core of the problem. This is data from India, and it shows that maize grown with irrigation produces more than double the harvest of maize that's just relying on the rain. That enormous difference is exactly the challenge farmers are desperately trying to solve.
So, the go-to solution to boost that rain-fed yield is, of course, fertilizer. You just add key nutrients like nitrogen and phosphorus to the soil. Sounds simple, right? Well, not so fast. The way we do it right now is, and I'm not exaggerating, astonishingly inefficient.
Okay, let's just look at the numbers from the study. When a farmer puts down nitrogen fertilizer, the crop only actually uses about 35 to 40% of it. That means 65% of that nitrogen is just gone. It washes away into the groundwater or gets released into the atmosphere as a greenhouse gas. And if you think that's bad, it gets even worse with phosphorus. The plant can only get its hands on about 15 to 20% of what's supplied. The rest of it, it just gets locked up in the soil, totally useless to the crop. Or it washes into our rivers and lakes, causing those nasty algal blooms. The bottom line is, we're paying for, and polluting, with tons of fertilizer that the plants never even use. Okay, so this is where the story takes a really interesting turn. Scientists started asking, what if we could be smarter about this? What if we could deliver these nutrients in a much more targeted way? What if the answer was nanotechnology?
So, what on earth is a nanofertilizer? Well, the easiest way to think about it is like a time-release capsule, but for a plant. Instead of just dumping a whole load of nutrients on the soil at once, this technology uses these teeny tiny microscopic particles that release the food for the plant slowly, right when and where it's needed.
And you can see the difference right here, plain as day. We go from this leaky, inefficient bulk system to a super targeted one. The study found that these nanofertilizers can have a nutrient use efficiency of around 51 to 58%. I mean, that is a massive improvement over the 15 to 40% we were just talking about.
But, theory is one thing. The real world is another. So a team of researchers in India set up this really rigorous 2-year field trial to see if this new tech, which they call nano-DAP, could actually live up to all that promise.
So here's how they set it up. They planted maize in a pretty dry region, so it was only getting water from rainfall. Then they tested a bunch of different recipes. Some plots got the full 100% dose of old-school fertilizer, and others got a reduced dose, but with this new nano-DAP added as a spray right onto the plant's leaves. The big question was simple. Could they use less of the old stuff but still get the same harvest? So after 2 years of carefully measuring and collecting data, the results finally came in, and what they found was pretty remarkable. It turns out they found a true agricultural sweet spot that could honestly change everything.
And here it is. This is the big reveal. This chart tells the whole story. The bar on the left, that's the harvest they got with 100% conventional fertilizer. Now look at the bar on the right. That's the harvest from the plots that got 25% less conventional fertilizer, but with 2 sprays of nano-DAP. They didn't just get a similar yield, they actually got a slightly higher one. I mean, just let that sink in for a moment. They got basically the same amount of food while taking a full quarter of the conventional fertilizer out of the system. This is the absolute core finding of the study, but believe me, the benefits do not stop there. So first, you've got the direct savings. This perfect combo required 25% less of the 2 most important and, frankly, most polluting fertilizers we use. Second,
the huge environmental win. Making and using conventional fertilizer is super energy intensive and spits out a lot of greenhouse gases. So, cutting back like this led to a nearly 25% drop in those emissions. And third, the energy savings. The total energy it took to grow that crop, from making the fertilizer to putting it on the field, was slashed by over 15%. It's just a more efficient system from every single angle. So what's so incredible here is that this isn't a trade-off. You don't have to choose between a good harvest and a healthy planet. This study points to a scenario that's better for the farmer's wallet, better for the crop, and better for the planet, all at the same time. This table really just lays it all out perfectly. For the farmer, this magic combo of 75% conventional plus the nano-DAP delivered the biggest profits. For the crop itself, it was the most efficient at actually using the food it was given. And for the planet, like we just saw, it meant a much smaller climate footprint. It's a genuine win-win-win. So what does one study in India really mean for the rest of us, for the big picture? Well, it suggests we could be on the verge of a huge shift in how we even think about feeding our crops. The authors of the study really put it best. They conclude that nano-DAP isn't just a simple replacement for the old stuff. They call it a strategic advancement. It's about shifting from this brute force approach to one of precision, giving the plant exactly what it needs, exactly when it needs it, and cutting out all that waste. Now, of course, the study makes it clear we need more long-term research in different places, on different crops, but it leaves us with this powerful and really hopeful question. In a world that's scrambling for more sustainable ways to feed itself, maybe the answer won't come from bigger tractors or more chemicals, but from something incredibly, incredibly small.